Yes, I want to speak about the Mosfet. Mosfet is a transistor device. Mosfet is a transistor device. First of all, you see the diagram of the Mosfet. The Mosfet diagram contains P-type substrate and a depletion layer, substrate, source, metal electrode, metal oxide insulator, drain VDS, source A, gate G, P-type substrate, N-type channel, and N there contains the Mosfet transistor. First of all, we have discussed about the Mosfet. It contains a JFET transistor. JFET transistor means junction field effect transistor. There is another type of field effect transistor available whose gate input is electrically insulated from the main current carrying channel and therefore called as insulated gate field effect transistor. The most common type of insulated gate FET, which is used in many different types of electronic circuit, is called the metal oxide semiconductor field effect transistor or Mosfet or short. The IGFET of Mosfet is a voltage controlled field effect transistor that differs from the JFET in that is as metal oxide gate electrode, which is electrically insulated from the main semiconductor N channel or P channel by a very thin layer of insulating material, usually silicon diode, commonly known as glass. This ultra thin insulated metal gate electrode can be thought of as one plate of the capacitor. The isolation of a controlling gate makes the input resistance of the Mosfet extremely high, way up in the megaohms region, thereby making it almost infinity. As the gate terminal is located from the main current carrying channel, NO current flows into the gate, and just like the JFET, the Mosfet also act like a voltage controlled resistor where the current flowing through the main channel between the drain source is proportional to the input voltage. Also like a JFET, the Mosfet has very high input resistance, can easily accumulate large amount of statistics charge, resulting in the Mosfet becoming easily damaged, useless unless careful handled or protected. Line of previous JFET tutorial. Mosfets are the three terminal devices with the gate, drain, and source and both P channel, PMOS, and N channel. NMOS Mosfets are available. The main difference this time is the Mosfet are available in two basic forms. Depletion type. The transistor requires the gate source voltage VGS to switch the device off. The depletion mode Mosfet is equivalent to the normal closed switch. Enhanced type. The transistor requires a gate source voltage to switch the device on. The enhanced mode Mosfet is equivalent to the normally open switch. The symbol of basic construction for both configuration of Mosfets are shown in there. The symbols of the Mosfets are there. The enhanced Mosfet channel construction, NPN transistor and PNP transistor. These are N channel Mosfets. These are P channel Mosfets. Subtract enhanced type of normal off. This is turned in off. The drain source is upper and source is lower. Gate is this side, subtract is this side, and depletion type normally on. It will on. The subtract is there, the drain is there. Next page. The Mosfet symbols above the shown additional terminal. In the last page, the Mosfet symbols are shown in there. The normally used the either input or an output connection, but instead it is used grounding and subtract. It connects to the main semiconductive channel through a diode junction of to the body metal tap of the Mosfet. Usually in discrete type Mosfets, the substrate lead to connected internally to the source terminal. When it then this case has enhanced types of omitted from the symbol for clarification. The line between the drain and source connection represents the semiconductor channel. This is the solid unbroken of the represent depletion. Basic Mosfet structure and symbols are already seen in there. Next we will see the construction of Mosfet. The construction of metal oxide semiconductor FET is very different to that the junction FCT. Both the depletion and the enhanced type of Mosfet use an electrical field produced by a gate voltage to alter the flow of charge carriers, electrons for N channel or volts for P channel through the semiconductor drain source channel. The gate electrode is placed on top of very insulating layer and there are the pair of small n-type regions just under the drain and source electrodes. We saw in the previous tutorial that the gate of the junction field effect transistor JFET must be base biased in such a way as a reverse bias of PN junction with a insulated gate. Mosfet device no such limitation apply, so it is possible to bias the gate of Mosfet in either polarity positive or negative. Next page. This makes Mosfet device especially valuable as electronic switches or to make logic gates. These Mosfets are used to make logic gates. In the negative and positive charges are there, and the NPN transistor, PNPN transistor also there in the Mosfet. Input resistance means that very little or no control current is needed as Mosfets are available in two basic forms, enhanced type and the depletion type. Next we will see enhancement mode Mosfet. The more common enhancement mode Mosfets or E-Mosfets. In the reverse, the depletion mode type. Here the conducting channel is slightly doped or even undoped, making in conductivity. This result in the device being normally off. Non-conducting when the gate bias voltage VGS is equal to 0. The circuit symbol shown above for the enhancement MOS transistor uses a broken channel line to signify a normal open non-conducting channel. For the N-channel enhancement MOS transistor, a drain current will only flow when a gate voltage VGS is applied to the gate terminal greater than the threshold voltage level in which conduction takes place, making a transconductance device. This application of a positive gate voltage to a N-type Mosfet attracts more electrons towards the oxide layer around the gate, thereby increasing or enhancing the thickness of the channel, allowing more current to follow. This is why this kind of transistor is called as enhancement mode device, as the application of the gate voltage enhances the channel. Increasing the positive gate voltage will crush the channel resistance to decrease further, causing at increase in the drain current IP through the channel. In their words, for the N-channel enhancement mode, Mosfets turns the resistor on while a 0 VGS turns to transistor off. Then the enhancement mode Mosfet is equivalent to a normal open switch. The reverse is true of the P channel. For the P channel enhancement MOS transistor, when VGS 0 device off and and the channel is open. The application of the negative gate voltage to the p-type Mosfet enhances the channels.
Restart.
Next we will see the enhancement mode, n-channel Mosfet and circuit symbols. This is a graph. First of all we see the graph in lower level, and 1 2 3 4 5 6 7 levels are there. One is 0 volt, another one VGS is 1.0 volt, another one 2.0, another 3.0, and top 2 is 4.0 and 5.0. in the one step increase here. This is a charge in upper level. It is a saturation region, VGS plus VE, and the N channel and P channel circuit diagram is given there. And we will see about the enhanced mode. Mosfets make excellent electronic switches due to their no resistance and extremely high out resistance, as well as their infinitely high input resistance due to their isolated gate. Enhanced Mosfet are used in integrated circuit to produce CMOS type logic gates and power switching circuits in the form of PMOS P channel and NMOS N channel gates. CMOS actually stands for complementary MOS, meaning the logic device has both PMOS and NMOS within its design. Thank you.